Excellent. So I'm assuming everyone can hear me. So here we're going to, last lecture, we had done a quick refresher on interfaces and abstract classes and concrete classes using a employee metaphor that we looked at in 1583. So I want to continue that, but I want to explore probably interfaces in a way that we hadn't explored it. And this will likely lead up to like the first basic homework that I'll likely go ahead and give to you. So today's lecture, I really want to focus on showing a new technology. So last lecture, I introduced IntelliJ. This lecture, I want to introduce some tooling that'll help us start producing our own API. And I want to kind of define what it means to program by contract or to design by contract. Let's actually change this to be the more appropriate design by contract, which is effectively how we end up designing our APIs, which we've used before from Oracle's webpage, and then we're going to look into how we can start building those ourselves. So before I start, is there any questions from last lecture? And it's my understanding that the lab component had already kind of started to go over or reiterate over some of the similar concepts we went over last lecture. Okay. Well, if there's no questions, what I'd like to start off by is opening up another project. Let us go to, so I'm going to go into IntelliJ here, and I'm assuming everyone can see my screen. And I'm going to select this item demo, because here I think this will be a little bit more interesting of a demo than the employee. We'll take that employee demo and that payable demo that we did, and it'll expand these concepts some. So what do I want to look at here? So let's look at our main method to see what our main method, how we're actually going to test this out. And here I want to illustrate how we're going to start taking advantage of the concept of interfaces. So let me go to my potion here, because inside of this JavaScript application, inside my main class, I have my main method. And here I'm going to just play around with a potion. So here, the purpose of this little test application that I'm going to do a quick walkthrough of is to go ahead and start to design conceptually how we might create a item hierarchy for a RPG or a text-based RPG on Java. And what considerations we might want to have if we were to implement this system using object-oriented principles that we've been covering. So how to use Java's interfaces, how to use Java's abstract classes, how to use Java's concrete classes to design a system that's robust, that's flexible, that's reusable, and one that isn't viscous. So let's take a look at this. So I'm going to open up Potion, because all we're really doing here is calling some methods on Potion inside our main method here. And so what, we're creating a Potion, and then we're printing out the state, and then we're telling the Potion to get consumed, and then we're printing out the state, and then we're telling the Potion to stack more potions on top of it, right? So take the potions that we had before and stack. And again, a nice thing about what a IntelliJ does is it lets me know what this parameter is. So quantity here, and then we're going to print that out. Then we're going to tell the potion to get destroyed, and then we're going to print that out. And then we have these two function calls just to illustrate concepts related to inheritance. So let's go and do a backtrace. Let's see what's actually happening here. So as we've stated before, and I don't know if you've actually seen this in practice, Java is single inheritance for classes, but it's multiple inheritance on interfaces. And that's that fact that we can inherit or we can implement on top of multiple interfaces is super powerful. And we're going to really want to take advantage of that when we start designing our software. So let's suppose we're actually in the design phase of building out an item. Well, one of the first things I'd want to do is I'd want to start defining what are attributes that are possible for items. So let's not look at Potion yet. We're going to come back to Potion. Let's talk about designing things. So let's say that, well, it might be possible that an item is equipable. And so I might define an interface called equipable, and an interface, as we've already covered, has abstract methods. So here it gives us the ability to think, okay, there's this property that some items might have, but not all, that would allow the user to interact with it in some kind of way. And so we would define the functions or the methods that type of item, an equipable item, would be able to perform. In this instance, we'd say you can equip it. Then let's say that there's another type of item, property or attribute, that's called consumable, where the idea behind what drives this type of item would be that we can consume it. And it's possible that an item could be both equipable and consumable, but those are two different actions, the ability to equip it and the ability to consume it. It might be possible that we can only consume that item. It might be possible we can only equip that item, in which case we'd only use the interface that is appropriate. Let's keep continuing down this thread. Let's say, okay, items can be equipable, items can be consumable. Maybe they can also be breakable. Maybe our sword could break if we use it too much, or after we go ahead and or your armor could potentially break, or any other thing. So perhaps you want to be able to have a key that once it gets used, it breaks. It's a common attribute that's found in RPGs though, right? So then we would go ahead and define what functions, what methods would a object that is breakable have to perform. Let's say it's destroy. So our equipable would have equip, our consumable would be able to be consumed, our breakable would be able to be destroyed. Okay, another common thing in an RPG setting like this would be the ability to stack common items on top of one another. So perhaps you can have a collection of potions or a collection of scrolls. Well, we could create an interface called Stackable that would have the function to be able to stack. And notice what this function declaration is doing is it'll actually take a parameter. I think the other ones that didn't bother taking parameters, right? Nope. So this is the only one that's taking a parameter, at least in this example. And notice the parameter type it's taking is of data type stackable of its own type. So conceptually, what's happening here is if you pass in a stackable item, on this stackable item, you're going to combine the two. So these are pretty much defining the attributes as we start plotting out how we want our items to work in our game. We can start defining the various properties that are common to some items, but maybe not all of them. And we define an interface. And now the beautiful thing about an interface is that it's just abstract methods. So it allows us to focus on parts of our software at any given time that our objects will have to implement. So this really helps facilitate the design phase. Okay, so now that I have these interfaces, how can then I move forward to actually start building my items? Well, a common thing, a common approach would be then to define maybe the most base case of what items have. And so this is where it would behoove us to start creating an abstract class. In this instance, item base is never designed to be instantiate it on its own. It's too abstract. But what item base does do for us is it goes ahead and it contains all of the shared data that every item might have. So we might identify that every item has a value, a gold value. So we will define that as a base property of all items. And then we might also define that every item might have a name. So we might define that as a base property. Now, when we define these instance variables inside our abstract class, we can do this in one of two ways. We can either define them as private. Now, if we define them as private, any of our subclasses won't be able to directly access them. That's the safest way to implement these. Notice I did not decide to do this as private. I decided to show an alternate way where I could also use the keyword for our access type here to be protected. And this would allow any inherited class to access these instance variables as if they had full membership of it. So to external classes that don't inherit from item base, they would be treated as private, but from any inherited class, they would be treated as something that is a part of that class. So it would be treated as something as if it was public to it. But just understand that one of the dangerous things about using the protected keyword is that it potentially allows a developer to come behind you, extend your class, and actually mutate the state of your variables in ways that you would normally consider invalid, right? So just keep in mind that that is a potential issue where some other developer can cause your class to become invalid. But if you're developing the entire hierarchy, that's not so much a concern. If you aren't, then that is something to be concerned about, right? So just keep in mind that there is a place for protected, there's a place for private, and it's really up to your own discretion on what you want to use. If you want to ensure that everything is as protected as possible, use the private keyword. But I don't, sometimes building just using getters and setters everywhere can kind of, in order to be able to mutate the state of the parent classes, can actually make the code harder to read. So if you're, so that's really, it's the classical argument of convenience versus security. You're most secure making everything private, but it makes it a little less convenient. It's more convenient to make it protected, but it makes it a little less secure. And so you just have to always determine what works best for you in any given situation. Okay, I went on a bit of a tangent there, so let me get back to the entire point of covering our item base. So we're going to create a constructor that will allow us to take in two parameters, right? Or we'll have two parameters, so allow us to take in two arguments where we'll be able to bind those values to our instance variables inside the abstract class. Now, again, we can never actually instantiate this because it's defined as abstract. But since this is a class, we can actually have some well-defined methods, some concrete methods, as well as abstract methods. In fact, do we have any abstract methods? We don't actually have any abstract methods. So this is another instance where we don't have to necessarily have an abstract method to define a class as abstract. Defining a class abstract prevents it from being instantiated. So if it's your intent never to have it instantiated, you can have a well-defined class where all of the methods are concrete, where none of them are abstract, and still make the class abstract itself, because your intent for that class is that other classes use it as a building block. And so that's the case in this instance, because all we have here is the ability to get and set our item values. And presumably I could remove these getters and setters if I wanted to, since I made my my instance variables protected, but I'm going to leave it as it was. Okay, so now let's move on to a stackable item. So let's open up this, and here our stackable item itself is designed to be abstract. So the idea behind a stackable item is that it is a special type of item, of a base item, but one that can be stacked on top of each other. So in this instance, I might go ahead and extend the item base so that I inherit all the predefined features that every base item has. And then this will also implement stackable, because the idea is that it's going to be a stackable item. So this is an illustration of what happens when we want to start not inheriting, because we're not inheriting anything from the interface, right? This is why we use the keyword implements. This is where we want to claim that we want to be responsible. We want to have access to the methods. We want to define the methods that all stackable items would have. So we want to be a member of the stackable attribute, or we want to be a member of the consumable things, or we want to be a member to the breakable things. So stackable items is claiming membership to things that are stackable. Okay, so what might stackable things have? Quantity and maybe a max number of things you can stack. Let's take a look at the constructor here. So we will take in an item value and a item name, because we need that for the base item, right? Our item base. And then we would take in a quantity and a max stacks for our instance variables inside this new class, this subclass we're making. And here, whenever we inherit from a class, so we're inheriting from item base here, since item base doesn't have a default constructor, we have to invoke it explicitly using the super keyword, and we're going to pass into the parameters to the invocation of our superclass constructor the two parameters it needs. So we're going to pass in item value and item name, and then we'll go ahead and then set for ourselves the value of quantity and max stacks. And then here, since we're implementing stackable, we'll be able to go ahead and override the method defined in this interface, which does not have a definition, right? So here we're going to take on the responsibility of implementing this abstract method in our interface. So let's jump back to our stackable item. And so here we'll just implement it this way. And so what's happening? Well, giving some stackable S, right? So if S is an instance of a stackable item, which is what we're implementing here, then the first thing we're going to do is we're going to cast it. So we're going to make sure that S is a stackable item, because we want to make sure that it's something we could stack on ourselves. And then we're going to do some checks. We're going to grab the quantity of this item, and then we're going to add it to the quantity that's being passed into the stack here. And if the summation of these two is less than the max stack value, then we're going to go ahead and update the quantity to match that. And then we're going to set the quantity to what was passed in here to be 0. Otherwise, we're going to see if the summation of the two is greater than our max stack value, then we'll compute the difference between the two. Then we'll set the quantity so that we add up to be the max value, and then we'll set the quantity of what got passed in to be the difference, so that you still maintain your two different slots of items if you hit a max stack. So let's say your max stack is 10, and you have a stack of 8 and a stack of 8, and you try to combine them, then one would go to 10 and the other would go to 6, is notionally what's trying to be captured there. And then we just have our methods get quantity and set quantity. Okay, so that's a very good question. So why are we moving from the variable S to the variable SI? So S is being passed in here. And so when we're implementing stack inside of stackable item, we can only stack a stackable item on top of another stackable item. It might be possible there are other things that are stackable in the games that aren't items, right? So that's just like this really abstract concept of stacking things. So let's say that there's other things that are stackable in our game. And for argument's sake, let's say that they're like bricks. And let's say that bricks aren't thought of as a item type, but it's defined as a terrain type. Then I might have a brick, which extends terrain item, which implements stackable. And I don't want, and so I don't necessarily want a brick to be able to be passed in to a stackable item method. So the first thing I'm going to do then is I might go ahead and check to see if the parameter that got passed in here, since this is as abstract as possible, is of the stackable item type. And then I'll go ahead and try to stack those things. And in fact, there might be method calls. More importantly, there might be method calls that are inside a stackable item that's not inside a stackable. Let's go look at stackable, for instance. Inside a stackable, there's only one method defined at this level, and it is stack. So that's the only method that I would have available to me when I declare a variable, when I declare a parameter as stackable. So again, since stackable is the data type that's being passed in here, the only method call I can get at that level will be giving me one method. So let me go back to my stackable item here. So, but notice inside my code block here, I'm trying to make invocations to get quantity and invocations to set quantity, right? So these don't exist inside of stackable, and I don't think that they should exist in stackable. The only thing that really defines something to be stackable, in my mind, at least when I did my initial specifications, was that it's that object, any object that was stackable, should implement the method stack. So now, since my implementation for stack requires that I access the ability to have the methods get quantity and set quantity, I have to cast the stackable into a stackable item, because stackable items are the ones that have this method get quantity and this method set quantity. And so I can't access these methods from this level. So what I'm going to do is I'm going to say, hey, is the stackable item that got passed in an instance of stackable item? And if it is, then the first thing I can do is I can safely cast it into a stackable item. So here I'm declaring a new variable of data type stackable item that I'll call SI. And then here I'm taking my value that got passed in, right? So I'm taking the reference of this stackable object. I'm like, well, I know that this is an instance of stackable item because I just checked it. So now I'm going to do a cast operation to cast it at the level of stackable item, so I get more access to the internal sets of methods. So now this is going to unlock for me with SI the ability to access get quantity and set quantity. And so since my implementation of stacking for this particular class requires access to those methods, I have to do it that way. I have to check to see if the more abstract thing is this more precise thing, and then I cast into the more precise thing so I can unlock more behaviors from it, right? Does that make sense? And the reason why we have to do that is because Java actually checks all of this during compile time and at runtime, and that's what makes it really efficient and optimized. But when it does checks on your method calls, it has to be that data type during those checks, during that kind of compilation step. Okay. So now stackable item itself is still abstract. So let's go back to something that might be a stackable item. So let's go back to the potion that we started with. Now, again, we started with our potion when we demoed, but clearly in the design phase, we started with our interfaces and we grew to our potion. So this would be now the time where we would honestly be implementing a potion. So here our potion is our concrete class. It'll be a potion. It's going to extend a stackable item, which is an abstract class, which itself extended base item, which was an abstract class, which itself implicitly inherited from object. So that means that potion has everything that object has. It means that potion has everything that base item has. It means that potion has everything that stackable item has. And now it has everything that potion has. Now, potion not only inherits from the class, the abstract class stackable item, but it can also implement off of the interfaces that we think a potion should have those feature sets of, those methods that it should implement and be a member of. So we think a potion should be a member of something that is consumable, something that you can consume. And we think that the potion should be a member of something that is breakable. So something that could be destroyed. And so what we're doing here is we're setting the potion up in a position where it will have to implement any abstract methods that's in stackable item, but it'll also have to implement any abstract methods that are defined in consumable and breakable. So here, let's go ahead and define our potion constructor. And so I'll define two constructors for my potion. I'll have one which has a explicit parameter of quantity. So how many potions are you going to create initially? And so inside of here, I'm just going to go ahead and pass to the parent constructor a default value for item. So all potions, let's say, for instance, in my game, cost 20 gold. All potions just have a name of potion. I'm going to pass in the quantity that got passed into my parameter here, where it belongs inside of the stackable item order of its parameter list. And then the default value of the max amount that you can stack is going to be 10. And then I'm also going to create a default constructor that will invoke my constructor here with the quantity set at 1. So if I just do new potion, it'll just make one potion. And now I'm going to override all my abstract methods. So let's say that I'm going to override consume from consumable. I need to do that if I'm going to be a concrete class, because I'm claiming I'm implementing this interface, which means I have to, right? I have to implement this method now that I've now effectively claimed that I'm going to have, because I want membership to this interface in consume. So I can define it however I want. So for the instance of this example, I'm just going to set my quantity to be less than 1. And then I'm also, since I'm a member of breakable, I have to implement a method destroy. So just for the examples of this, purposes of an example, I will go ahead and implement destroy to just set the name to broken bottles. So again, you probably have more complex logic in a real game, but this is just an example to illustrate how we might consider building out a deeply definable item sets inside of an RPG game, or like a crafting game, or any other kind of game where you have the ability to have all these different feature sets that your items can have memberships into. I'm also going to go ahead and override the default toString method so that I can actually just print out a string to see how the state of my object changes over time. Okay, so now that we've effectively covered everything here, we can go back to the main class, which is what we really started with, and we can see what's going to happen. So I'm going to invoke that constructor of potion, right, with the quantity of 5, and we're going to set that into a potion variable, and then we're going to print that to the screen. Then we're going to tell potion, hey, get consumed, and it has a consume method because it implemented that and it wanted that membership of being a consumable. And then we'll print out what the result is. Then we'll say, hey, potion, stack on top of you this new set of potions, this new stack of potions of quantity 10. And then we're going to print out the state of our potion. Then we'll tell our potion, hey, get destroyed because it's something that's breakable. And then we're going to print that out. And then just to prove that our potion has membership to things that are breakable and things that are consumable, that they can be considered a data type of breakable and consumable, we're going to create these methods that take in as a parameter breakable, that take in a parameter of consumable, and we're going to pass our potion into that. And then we'll just go ahead and print that. And we're going to print it with its class to see that even though it's treated as a breakable thing, it's treated as a consumable thing, we can still view it as its subclass, which is the potion class. So let me run this here. I can hit the green arrow. We will just run this main method and we'll just see what our results are. So here we can see when we run that code, we initially get our potions, right? They're 20 gold pieces a piece, and we initially created a stack of 5 out of a max of 10. And then here we consume a potion, which means we're going to reduce 1 from our stack. Here we're going to stack 10 potions on top of our pre-existing stack. So that's going to only allow us to have a max of 10. So we'd have a leftover amount here, but since I didn't bind that to a variable, I lost it. So I can't check the state of that. And then after that, I'm going to destroy my potions. So now notice my description becomes broken bottles. So I changed the item name. And then I'm going to test out these 2 methods. Here in print breakable, I have my class potion that got passed in, right? That's this first method where we passed in potion as a breakable data type. And then here in print consumable, I passed in potion as a consumable type. And here you can see it's recognized as a class potion. And again, by being able to identify it by its subclass, I can check it for its instance. And then I can even I can start accessing its subclass attributes and behaviors as long as I cast it. So does this make sense in terms of how I can start developing my code base by starting with interfaces and then defining abstract classes and then defining concrete classes from there? Excellent. So this is going to lead me in. So this is the real use case of interfaces. And so what interfaces are allowing us to do here is they're allowing us to create kind of like an API for our own kind of game. We can create methods that we know we want future objects to have. We define them as a set of interfaces. And then as we start defining our objects, we can just say, oh, yes, this object will implement these collection of interfaces. And then the beautiful thing about that is that object or that class or any instance of that class can now be treated as a member of any one of those interfaces. So you can start grouping them together in very intelligible ways that would be really complicated to do otherwise. And again, this adheres to the solid principles, which we'll cover in the future once we start getting a better understanding of these individual ideas. So what I'll probably do is a bottom-up approach, or where we'll start looking at all these things in isolation, and then we'll define what solid is and how it all plays into that. But I do want to move on. So if there's no questions as to that example, I kind of want to move on to just a couple slides to talk about how we're starting to design our objects. And so it's going to let us design our objects in a concept that is called design by contract. And so we've been designing by contract from the get-go, from probably your very first Hello World program. Once you start looking at APIs, you're designing by contract. Because what an API is it's a contract between you, the client developer, towards the server developer, the person who's providing those methods to you. So every time you go into the Oracle API and you look up what does system.out.print do, what does scanner do, you are adhering to a contract. You're going to see what methods are there. You're seeing what you have to give that method, and then you're going to see what that method gives back. And so as long as you give that method the thing it claims it wants, then you can expect to get back the thing it claims it's going to give. Now let's talk a little bit more rigidly about how we design by contract. And let's look at how we can start taking advantage of auto documentation tooling such that we can start creating our own APIs similar to what's hosted on Oracle's pages, and how we can create our own APIs that'll give us our little tooltips inside of IntelliJ. So let me make sure that I have my chat in here. Okay, perfect. So design by contract. Let's start thinking about things in terms of systems. So systems thinking. A system is any part of anything that you want to think about as an indivisible unit. So an interface is a description of the boundary between a system and everything else. So again, a system has some kind of boundary point, and it can have anything inside of it, and then they have things outside of that. And so a subsystem could be a system within a system. So let me give you an example. I'll give you another example on the next slide, but I'll give you an example right here before I move on of a car. So like the interface of a car is the steering wheel. It is the clutch. It is the brake pedal. It's the gas pedal, right? Anyone who knows how to use a steering wheel and the brake pedal and the gas pedal can start using the car. They don't have to know how the motor works, right? They don't know how the inner workings of the car has to operate. And so inside of this line of thinking, the car system has an interface that client users use based off of steering wheels and pedals and things like that. Now, the car itself has subsystems. It could be the engine, right? It could be the transmission. It could be all these nested inner components that they themselves have these interfaces to that the rest of the car takes advantage of. So just because something is a system doesn't mean it itself isn't made of a collection of subsystems that all are defined by their own sets of interfaces. And so we're going to see how just like a car is these like varying levels of complexity where they all interface with one another. Well, that's how our software is going to be. So there'll be all these levels of nested subsystems that interface with one another that build out into this really complex architecture. So again, here, another example would be like the ice water dispenser on a refrigerator, where you can select for the water to get select to have water, crushed ice, or cubed ice. You place your glass in and against the pad, and it delivers that contents, right? There's a selection that you want here, and there's some kind of output. Okay. So a client is a person or a role played by some agent viewing a system from the outside as an indivisible unit. And the implementer is the person viewing the system from within and who is assembling the subsystem and the components. So these are the two roles we play as developers. Either we're a client to a system or we're the implementer of the system. So one side of the coin is information hiding, It's a technique of describing the system. The behavior in which you intentionally leave out are those internal implementation details, things that only you have to consider and that you will abstract away from all of your clients. And on the other side of that coin is that idea of abstraction, where you are hiding all of the details that allow your system to work. And so here you'll bind things to some like method name, or you'll bind it to some kind of action, and you claim, give it this input, and I will guarantee you this kind of output. Okay, so using this kind of interface system where there is a distinct separation between the client and the implementer, this is a process that we call programming to an interface. And again, think about how you've used APIs before. You don't need to know how the scanner object gets everything, all the tokens from the stream, and then casts it into objects, right? As long as you know the method name and the data type, you can expect to get what it claims to get back. And then you don't have to be concerned about the rest of it. And so that process is called design by contract, or programming to an interface. So when we engage in this contract, right? So what's happening here is when we start using APIs, there's very much a contract that we are now engaging between the implementer and the client. And so every contract is going to have a precondition and a postcondition clause. The precondition is effectively a requires clause, and it characterizes the responsibility of the program that calls or uses that method. That would be the client code. And then every method would have a postcondition that we can think of as our ensures clause that would characterize essentially the responsibility of the program that implements the method. So this would be the implementer. So the precondition is the client will guarantee that they give the method the correct thing. So this method requires these things. And the postcondition is, well, provided you gave me the good thing, I will implement in such a way that I guarantee you I'm going to give you that thing back, right? That is the contract. So if the precondition is true, when a method is called, then the method will terminate, and it will return back to the calling program and give back whatever it claimed it would give back, or it would process whatever it claimed to process and then return control back to that invoking method. And the postcondition will be true when it does return. And so if its precondition is not true when the method is called, then there's no guarantee on what might happen. So if the client doesn't fulfill on the precondition, the method might not even terminate. It can result in an error. It could do anything. All bets are off effectively. So the responsibilities and rewards for both sides of this contract is that, let's look at the precondition. The responsibility, making sure that the precondition is true, is when the method is called on the client side. And the reward for the client is they can assume that the postcondition is true when the method returns. So the responsibility for precondition client, and they're guaranteed a reward of getting what they expect. The responsibility for making sure the postcondition is true when a method returns is that of the implementer. And the reward here is that the implementer may assume the precondition is true when the method is called. They don't have to necessarily check that themselves. Okay, this is this concept of design by contract is going to kind of lead me into, let's jump in, not to JavaDocs yet, to APIs. So the resulting documentation that we look at that defines these preconditions and postconditions is what we commonly refer to as our application programming interface. Now, in Java, our application programming interface documentation is created by a tool called JavaDoc. It's a standard documentation technique for Java, and it's an auto documentation tool. I'll talk about this in just a moment. But just as an example, and we've already seen this before, we can look at the API of an Oracle component at Oracle's website. I'm not going to bother going there because we've seen that we've seen that kind of documentation before, right? Well, yeah. Okay, let's look a little bit at the definition of API. So the resulting documentation is the API, right? So the word interface here has two related but distinct meanings. It's a unit of Java code that contains a JavaDoc comment used to produce documentation that is the resulting documentation. So our interface is both embedded in our code, and it'll be produced into like an HTML document that can then be read outside of our code. So let's start talking more about JavaDoc, which is the tooling, the auto documentation tooling we're going to use to start generating our own API that, again, will allow tooltips and accuracy to be had inside of IntelliJ, and could also be deployed as a web page and viewed as part of your documentation on your project code, your source code. So JavaDoc is a system for generating documentation from Java code. The JavaDoc binary utility has been included in the JDK since its initial release. So for as long as Java has existed, there's always been a JavaDoc to be able to auto-produce our APIs. It provides an easy-to-use way to document code in a standard uniform format. So it's really easy to start creating JavaDocs. JavaDoc content is always included within a special comment block. So you would use a multi-line comment, but instead of just 1 star, you'd use 2 stars. As soon as you have 2 stars in the opening comment block, it's now going to be treated as a JavaDoc comment. So an example would be this. I have a comment here, right? A block comment here. I'm using 2 stars, which now makes this a JavaDoc comment. And then I would have my normal implementation. So here I'd have my class. Then here I'd have my my method comment, and here's my method. And then I might have more comments that describe what the statements in my method does. But notice, since this has 2 stars here, this would be parsed by the JavaDoc tool. Since this has 2 stars here, this block here would be parsed inside the JavaDoc tool. Now, the cool thing about the JavaDoc tool is that once it starts parsing a comment block, there's special annotations you can put inside of your comments that will then get translated into your API documentation. So it'll be able to define like parameters. It'll be able to define what gets returned. It'll be able to define the descriptions. It'll be able to define other parts, your preconditions and your postconditions, for other developers to know what is expected when that's used. So let's take a look at an actual example. Here we have a comment block with 2 stars. So this is a JavaDoc comment. And so this is what's called an annotation. I can use the @ symbol and then some certain keywords. Param is a built-in keyword for JavaDoc that defines a parameter for this method. And then the next thing would be the name of the method and then the description. And then here we can also have a JavaDoc tag of @return, which would then have a description of what gets returned inside of this parameter. And so when this gets parsed, this will actually be used to define what are the parameters and the return values inside of the documentation. Then there are other JavaDoc tags we can use that are defined for developers to more critically evaluate what you designed in terms of what your preconditions and postconditions are. Now, I will say it's by convention that we use @requires and @ensures, but these aren't actually default supported tags. So if you use @requires and @ensures, this is really information for yourself while you're developing. It won't be part of the actual documentation that gets produced by JavaDocs, unless you create a custom tag for those. So let me just go back here, though. @requires, would define the precondition as we defined it earlier of what you'd expect this method to take in. And at ensures would define what your post condition is. So again, what's the word I'm looking for? Typically, the approach you would use is you would define your at requires and at ensures while developing to say, okay, this is what I expect to have in. And so the param here would be X, and that could be anything, right? The data type might be int, but what the at requires would state is restrictions on that int. So again, or this is a double. So notice what we're passing in here is double. What the API is going to let other developers know is, hey, you can pass a double into here. However, what you're going to require inside of your precondition is that double value, in order to be valid, in order to get that post condition, has to be greater than X, and the epsilon value has to be greater. X has to be greater than 0, and epsilon value has to be greater than 0. See, so it can't be any double value. It has to be double values that are positive. And so you might put that as part of the description in the param once you deploy your code, but during development purposes, you can have an at require and at ensures just to let all other developers know that, hey, these have to occur. And you can actually enforce that with assert methods. So it's also possible inside of this code block, besides using these annotations, to also use HTML. Recall that the API that gets produced is nothing more than HTML documentation. So we can actually embed HTML syntax into our code block, and the JavaDocs tool will actually parse that and convert it into the appropriate HTML. And again, the requires would define the precondition, indicating the arguments passed in for the formal parameters of X and epsilon must both be positive. And here we'll then define our post condition as indicating that the return value from square root is non-negative, and it will return a valid value. Okay, so using a method contract, a static method or an instance method, doesn't matter. Contract refers to its formal parameters, and only if it returns a value, not void, to name of the method for its return value. And so to determine whether the precondition and postcondition are true for a particular client call, well, it's defined. So the model values of the arguments are substituted for the respective formal parameters. So the formal parameters is anything that's valid. And so when you go to test that, you would go ahead and take a value from the set of what are legal values, and you make sure that it works. And so the model value of the result returned by the method is substituted for whatever that method name is. So that would be whatever he is inside of the ensures here. Okay, and so to ensure that your preconditions are valid while you're developing your code, you can do these assert methods. So you can assert that X is greater than 0.0, and then actually have a string that sends a message for the exception that'll get generated if that's not the case. So these assert methods, again, are used while you're developing the code and removed after you've actually gone to deploy to the client code who you're trying to hide these details from. So again, there's like this staging time as an implementer where you want to have your at ensures, you want to have your at requires, and you want to have these asserts so that you can guarantee that everything's working for yourself. But then when you go and deploy this, when you share it with other clients, then you'll hide it behind the API, and then it's just going to be a collection of parameters and return values. But you'd give a description of what's expected, that the X value adheres to these preconditions. So the assert statement in Java checks whether a condition and assertion is true. If it is not, it stops execution or reports the message after the colon. But why are the assert statements in this method body to check? when the implementer is supposed to assume, right? Well, during software development, it is a best practice to check assumptions with assert when it's easy to do so. And the preconditions generally are easy to check. Postconditions are not as easy to check. So check that things passed in, and then produce whatever the result is after that. And so you're always just checking, since usually since objects interact with each other through message passing by invoking each other's messages while you're testing everything, you can just check while it's initially getting passed in. So a misconception here is a common misconception is that assert statements to check preconditions contradicts our design by contract principles. Remember, our principles is it's the client that checks themselves to make sure they're passing in valid data. And then it's the implementer who assumes the data is valid, who then will produce a result under the assumption that the data is valid without checking it themselves. So it does not, because the advice is not to deliver the software with the assertion checking turned on, but rather to develop software with assertion checking turned off. Okay, let's go back to JavaDocs. JavaDocs uses tags, as we already saw, to annotate certain properties of classes or methods. And so we have like @author, which is a tag for defining what the author class is. We have @version, which can show the version of the class. We have @since, which shows when the method or class was introduced. We have @c, which lists the reference to another class or method. So these are all the built-in types. We have @param, @return, which we saw. We have @throws, which will show what can create an exception. We have @deprecated to indicate if the method is deprecated or not, to allow your clients to know that they should migrate to another method. And we have @inheritDoc, which automatically inserts superclass JavaDoc properties. And then again, as I mentioned before, you can also use HTML tags inside of a JavaDoc comment block, which will allow you to format your comments in a aesthetically pleasing way. And so you can generate your HTML from your JavaDocs one of two ways. You could either do it from the terminal, just using the keyword JavaDoc, just like you use JavaC or Java, and then you can pass in D as a flag and the directory that you want your JavaDocs to be written to, and then the Java file you want to produce the documentation on. We can also produce our JavaDocs using IntelliJ, which I want to show you today. So let's look back at this client server model. So when we define programming by interface, or this concept of design by contract, what it's classically referred to is a client server model. So we can think of the invocation of a method as a transaction between two entities, between two objects, the client and the server. The client is the portion of the code that calls the method, and the server is the portion of the code that executes the method. So for example, suppose you have a class dog that has a method bark, and we also have a class dog trainer that invokes the bark method of a dog object. The client would be the dog trainer, and the server would be the dog object that is running its bark method. So it's just like the square root, but we can start seeing how this, we're going to take a step back and see how this actually operates between client code or client object and server code or implementer code and our server object. So here, my dog trainer object would be the client. My dog trainer would be the client. My dog object would be the server. The dog trainer would try to tell the dog object to bark by invoking its bark command. So the point of doing this is to have the checking that the invocation of the method makes sense in terms of the data that goes in and the data that comes back out. So again, this is just the concept model that drives a design by contract. So data goes in by parameters and it comes out by return values. So if we modify our example a bit and imagine that there is a parameter that actually gets passed into the bark method that represents how forcefully that command is given, i.e., let's say it's the decimal level of the trainer's voice. So instead of just commanding the dog to bark, we will use a certain decibel value for that command. So here on our dog trainer, when we do bark, we're going to pass in a value. So, okay, so if the trainer voice is, say, a float representing the decimal level, there must be limits on the meaningful values of this number. Although a negative number is allowed as a floating point number, clearly it would be meaningless in the use case of a decibel level. It doesn't make sense to have a negative decibel level. So as we've already mentioned, whose job is it to check whether this is valid, negative or not? It's the client's, right? Checking the value of the trainer voice can be done by the dog trainer, right? By the client side. It could be done by the dog object. It could be done on both sides, which would be completely unnecessary and would violate the dry principle. So we wouldn't want to do that. So if we don't check at all, that would also not be great, because that would lead to all sorts of erroneous errors. So again, the point of thinking about this, about who the client is and who the server is to, again, think in terms of who's responsible for the preconditions versus who's responsible from the postconditions from the actual software entity perspective. So the data into a method will always represent the client trying to transact another object. And then the data out will represent the server of an object returning back some data to a request. So since the method itself is the unit to which the client server model is applied, we label the method with JavaDoc Comments stating the conditions of the client server contract. And again, we stated that there were the preconditions of this contract, the postconditions, and the invariance. And so here, the preconditions must be true at the beginning of execution of the method. And often you will place bounds on the values of the parameters so that the client knows what is required of them for the method to work. And the postconditions must be true at the end of execution of the method. And often bounds are placed on the return value so that the client will know what scope the return value will be. And so that will be the responsibility of the server. Postconditions often are used to make explicit are pretty explicit about how an object's state will have changed at the end of the method. So again, when we're talking about state change, we need a shorthand talk about what the state was when the method started. So we'll use old in this instance. So in this instance, when we have our ensure, we will say that the count will be equal to the old count plus 1. Also remember that when you use method calls in the syntax above, I assume that the class has a query method get count. Okay, so for invariance, so we covered preconditions and postconditions at least 2 times over this lecture. Let's talk about invariance. Invariance must be true all the time. So where preconditions must be true at the start and where postconditions must be true at the end, invariants are things that have to be true throughout the entire cycle of this transaction between the client and the server. And so often you might place bounds on instance variables and their responsibility of the programmer, the server. So invariants and postconditions are both responsibilities of the server. Preconditions are responsibilities of the client. And you can use an @invariant inside of your JavaDoc label to illustrate that this always has to be true. They can never, ever be allowed to be outside of whatever that defined bounds is. Okay, so now that we've got data coming in being tested once by the client, and we have our data coming out being checked once by the server, a clear definition of what the server expects from the client and what the server promises the client, we now have our contract defined. And so if the client breaks the contract, we promise nothing. And if the client abides by the contract, they will get a result without having to worry how that result was derived. Now, one thing we have to be considerate of is subtyping and extending classes. So you need to be very careful when extending classes or implementing interfaces. And so this can be a very subtle point because again, if the client breaks the contract, the server promises nothing. So let's imagine here that we're talking about our dog class from before, and we've got a bark method that looks like the following, where the return value now is the decibel level of the bark produced by the dog. So here we have our requires is checking that the trainer voice is greater than and equal to 0, and that the trainer voice is less than or equal to 100. And then we'll assure that the bark is greater than 0 and the bark is less than or equal to 200. So here now, suppose that we want to define a class poodle that will override its parent class's bark method from dog, and it defines it as such. So the poodle's bark will require that the trainer's voice is greater than or equal to 0, and that the trainer's voice is less than or equal to 100, and that it will ensure that the bark is greater than or equal to 0, and the bark is less than or equal to 200. So consider what the options are for our pre and post condition. So the precondition may be made to be more relaxed in a subclass, but more restrictive. So the idea is that as you start extending classes, you can open up the bounds of the precondition as opposed to the superclass, right? Now, the idea behind extending a class means that it is everything the parent is, but it can potentially do more things. So you can extend the bounds of what gets passed in, but you can't make it more restrictive. So I can't make poodle allow for less decibels than a dog, because a poodle is a dog and all dogs claim to allow that bounds on preconditions. So you can't strengthen the preconditions in subclasses. You can only make them more restrictive, because a poodle is a dog, plus it can handle its own new sets of behaviors. And post conditions inside of our poodle may be more restrictive. The thing we return back, we can limit the bounds on, but we can't relax it more, right? So there's an inversion there. So a poodle, so on the post conditions, we have to we have to operate inside the bounds that dogs required to, but we can actually be more narrow inside those bounds for a poodle. But we can't be less, we can't open those bounds out more. We can't go beyond what dog claimed to be necessary of. Now, that's something we have to adhere for, right? That's not something that Java necessarily checks for. So these are all programming conventions where we're defining contracts between developers. Does that make sense? That's usually when we start talking about programming by interface and creating these contracts between our client and our implementer. The thing that gets confused most cases, I think, is this concept between how we can extend. And so just keep in mind that the rules for poodles or your subclasses have to maintain all of the rules by the superclass. They're not allowed to break them. They can make them more rigid or on the return values. They can make them more lax on the incoming values, but they can't do the inverse of that. Excellent. So how's everyone feeling about this idea? So does everyone see how these rules, these design principles tie into the example code I started out with the interfaces? How what this interface represented was an API. Here, an API of a stackable, an API of consumable, what consumable needs. So the client, the thing that's going to implement that, then has to go ahead and create a definition for this. And then we can create our documentation for that to be supported. And actually, why don't we do that? Let's create a basic JavaDoc file to see how that would happen. So let me go here. Let me create a new project. Let's see here, IntelliJ, new project. And let's just call demo. Let's call this JavaDoc demo. Okay, so here, let's create that. Let's create this in a new window. Okay, so now I have my project. And so what I'm going to do here is I'm going to create a, let's say I'm going to create a new, I could do class. Let's do an interface. So let's do this. Let's say that this is my math. So we'll make an interface here that I'll just call iMath. And here I will create a public. And let's say that this is double square root that takes in a double square root, right? Okay. Oh, wait, no, it's not that. A double X and a double epsilon. Okay, perfect. And let's see, what can I do here? Let's go here and create our block. So I'm going to do a JavaDoc, so 2*, and notice what it does for me. IntelliJ will automatically populate that with the annotations that will give me my parameters and my returns. And then this is the name that I can apply. So a description to this. So let's say this is the number to take the square root of. And so here, let me give this a description. So epsilon allowed relative error. And so here, let's do our return will be x is greater than 0. I'm sorry, our return here is going to be our description. So this is the approximate square root of x. Okay, so I'm going to define the actual data that will go into the documentation for all the clients, but then I can come back around if I wanted to and define those insurers. So I can say we have to ensure that the data is, well, I'll just do this in the parameter section here. So ensures that, so we require, so here I'll just put, make it easy, x is greater than 0. Here I'll put x is greater than, not 0, epsilon. Now, by convention, I can have those at require, so I'll put them. But you're going to see, I'm going to get, IntelliJ is going to tell me something when I do this. It's going to tell me, and then I'm going to do the same thing, that x has to be greater than 0 and that epsilon has to be greater than 0. And then we would ensure the square root is within a relative error of actual square root. Okay, so I could do that, but notice this is highlighting for me. And so it's telling me if I go here, it's gonna make some recommendations. But I'm being reported here that it doesn't recognize these as default tags. It's saying, hey, that's a wrong tag ensures. It's not part of the default settings because this doesn't, the requires and ensures don't go into the documentation. It's the params and returns that typically go in. Actually, let's generate this really quick. Let me save this and let me go to tools and just go to generate JavaDoc. And so when we generate a JavaDoc, we have to list where it's going to deposit your HTML files. Usually you don't want to deposit them inside of your source code file, right? So actually let's tell it we want to deposit it inside of a new, it's called docs. So I'm just going to say, okay, inside of our project, let's create a directory called docs that we're going to generate that into. It's not going to like that I have these at requires and at ensures. So it's probably going to say, while I was going through this, oh, I didn't give a description for interface. So it doesn't like that. So I get a couple of warnings. I can click here to see what the warnings are, that the interface iMath is never used. I have a wrong tag for ensures, and I didn't take its suggestion. that these modifier public is redundant because by default it's public inside of interfaces, and that square root is never used. So these are warnings that are letting you know this code's never being used, but it worked, right? I can go here and hey, where'd my doc go? Great. Let me do that again. Let's go to tools, generate JavaDoc. That should be, oh no, that's not right. Let's go here. Cancel that. Let's actually put it in the appropriate place it needs to go. So let's go here. Let's I can't. Okay, let's do this. Let's go to users. Let's go here. Let's go to my projects and let's do, what's this called? JavaDoc demo here. Okay, let's go there. And now let's create docs in there, generate that. And so when it does that, I should now get this docs directory, which now, if I look, has a HTML file. So let's take a look at our HTML file, and I should have the option here to open it inside of Chrome. And there it is. Look, looks just like what we'd expect our implementation will look like on Oracle's website. Right here, I have a modifier and type double, that's return type. Here's the method. Here's the parameter list. And notice here in the description, I have the parameters because of the app params with my name and description. And then I have my return value here. So it's that easy to generate these really nice uniform looking API documentations by using JavaDoc Comments. So every time moving forward that you're producing Java code, you should be using JavaDoc Comments so that you can automatically create these documentation pages so that all client developers that come behind you can easily read what your class is capable of doing, because this exposes the public methods. This exposes what you guarantee your class will do for other developers. This defines that contract that you've implemented as an implementer that your clients can now utilize. This is effectively your menu of options for your built-in systems that you've designed. And so your system might be a subsystem to some larger system, but all systems should be taking advantage of this so that all other developers can easily read what are the requirements, what are the preconditions for all the publicly exposed methods. Okay, does that all make sense? Let me go back to my chat here. Excellent. Okay, I'm kind of out of time here, but I think I got everywhere I wanted to be here. We went over a pretty decent example of how interfaces are actually used for developing and designing more complex code bases using an object-oriented approach, which then introduced this idea of designing by programming by interfaces and designing by contract. And then we went ahead and exposed a new tool for you to use that allows you to define your own sets of API the exact same way that Oracle's API is defined by, and how easy it is to generate using our integrated developer environment. Although it's not that complicated to use from the terminal either. You just use the JavaDoc command. And just make sure you put your documentation pages in its own folder. Otherwise, it's going to be a big clutter inside your source code file. Is there any questions before we end today's lecture? Excellent. Well, everyone have a great day. Yeah. Oh, that's a good question. I will go ahead and post these slides as I create them or as I approve them into the Moodle. So yeah, I will. I'll probably also do that with the sample source code that we have as well. So please remind me to do that on Discord if for some reason I forget. And then I'll go ahead and publish this video as soon as it becomes available. Let me